Hi, we're the Advanced Snowmobile Enterprise here at Michigan Tech. Our main goal is to improve and innovate current production snowmobile like this one here. We compete every year in a competition in Eagle River, Wisconsin, where we compete for reducing emissions, reducing noise, and improving handling. Our team is split up into 4 sub-teams, which are spark ignition, hybrid, chassis, and electrical. We are gracious to be able to say that we are 2-time champions of our competition.
So here on the chassis team, we focused mostly on sled setup and rider comfort. With that, we did a few projects to help improve these things. One project we did implementing on this year's competition snowmobile was implementation of stiffener plates. We verified this through modal analysis and FEA to prove that we saw better lower frequency vibrations to help increase rider comfort. Another thing we did to increase rider comfort too was suspension tuning. We did this through accelerometers and a test rig with a consistency between our tests to determine which shock and settings had the least amount of G-forces experienced by the rider. And then we also did a lot of sound testing to help validate all of our other projects as well. We did some sound testing with different tracks and different setups in the rear skid. We also removed all of our bogey wheels, which we saw major reduction in sound levels, which would be greatly impacted on our competition for next year. Some future projects that our team is going to be working on is this long travel front suspension that'll also be wider to improve our stability and handling on the trail. And then we're also going to be working on a larger driver design. This will help increase efficiency and overall, and will help lower noise too on the sled while it's in operation.
Alright, so over here at Hybrid, we're working on a parallel hybrid system. It's driven by this 72-volt electric motor, as well as this controller here and this battery. We're going to have all of our safety system inside of this battery box here, which we're constructing now, and I'll let Dylan talk about that.
Yeah, with the implication of the hybrid system, we need a bunch of supporting modifications. So a frame that has to be able to withstand 20 Gs, so the battery doesn't go flying out of the frame. Controller mounts, motor mounts, and they all have to be structural members, so we're running FEA and analysis on those to make sure that everything is rules compliant.
Here on the electrical team, we usually support everyone on it, but we mainly are working with the hybrid team on making a hybrid dyno, integrating the electric motor with our water braking system. And on the chassis and SI side, we are working on the safety features, and so we can follow the rules for the competition.
Here at the SI team, we primarily focus on the engine calibration and exhaust tuning. Right here is our stock muffler that came on the sled, and then over here is the custom muffler that we designed, tested, and simulated all in-house. This past competition, we integrated a 2-way catalyst into our muffler to farther reduce our emissions. This upcoming year, we're planning to advance this even farther. This is currently not done within industry, but in order to make it work, we need a lean engine calibration to farther take advantage of the catalyst, as well as lessen the heat buildup associated with it.
For our Enterprise Capstone project, our group designed and manufactured a secondary dynamic exhaust valve. This valve aims to reduce emissions and fuel consumption while also increasing power. This valve targets low RPM and throttle range where 2-stroke engines are very inefficient and produce a lot of emissions. This valve works by changing the back pressure in the exhaust system to increase the trapping efficiency of the engine.
2-stroke engines expansion pipes are designed to influence the gas exchange process, making the design and implementation of this valve quite difficult. For our valve, we are controlling it based on the user input throttle percentage as well as the engine RPM. And we are currently in the calibration and validation stage of our project.